Hey everyone, so as we were discussing about the amino acids, now let us look at the property of Zwitter ion. I know I have talked it briefly, but understand the structure now. Okay, so for example, we have a alpha carbon, and then we have a carboxylic acid group and NH3 positive group. There's a R group, and then there's a H group, right? So now in physiology, it can occur in like positive ion, neutral, or negative ion. Okay, due to which it has buffering ability. So all amino acids are weak acids. Okay, you must remember this for MSQ section for both GATE as well as IIT JAM. Guys, whatever I'm bringing, it is very important because I know nobody teach it, but this question comes in both the GATE as well as IIT JAM. Okay, so for example, as you can see here, right? So there is one titrable proton group, right? There's one titrable proton group here. So they have at least, all amino acids have at least two titrable protein. Okay, two titrable proton, not protein. Titrable proton. So the proton and protein mixed up. Okay, so some amino acids can have three or even more protons that we are going to look, and it is because of the R group present. So if you are familiar with the previous lecture where we have discussed about the positively charged amino acids and the negatively charged amino acids, right? So there you must have studied about the aspartate as well as the glutamate. So these have titrable proton that we'll be discussing. Okay, so let's suppose, so we have NH3 positive group, C COH group, then there's H, and then there's, let's suppose, an R group, right? So when a proton dissociate, right, so then it will have NH3 positive, C, COO negative, R, and H. So here it existing as a Zwitter ionic structure. Okay, here it is positively charged, right? So when another proton will dissociate, so it will be NH2C, COO negative, H, and R. You do not need to remember which H positive will go first and which not. So usually it is the carboxylic acid group where the proton get released first and then the NH2 group. Why? It is not important. So if you're studying, so go for the Leninger book. So you'll get to know why the carboxylic acid release first and then the NH2. Okay. So for example, if we take example of alanine. So alanine has CH3 group, right? So C, CH3, COH, NH3 positive, and H. Currently it is in a positively charged structure, right? So at the very first pKa it will lose one proton, so then it will be NH3 positive, C, CH3, COO negative, and H, right? So now it has a Zwitter ion where it is neutral. So Zwitter ion is basically neutral structure, right? So when another proton will be released at different pKa or pH, so it will be NH2, C, CH3, COO negative, and H. So now it is negatively charged amino acid. So are you getting? So every amino acid will have two pKa's, okay, at any given point of time. So now if we look at the structure of aspartate, right? So what is the structure of aspartate? There is CH2, then COOH, right? So this is the structure of aspartate as far as I'm correct, right? So now currently it is in a positively charged, as you can see. So at the pKa, at the very first pKa, when proton will be released, okay, so it will have NH3, C, CH2, COH, COO negative, and H. So it will have Zwitter ionic structure right now, right? So at another pK or pH, what will happen is another proton will be released. So C, COO negative, COO negative, and H, right? So it will have a negatively charged. So it has -1 valency, right? So when another proton will be released, so at this point of time, NH2, C, CH2, and then wait, then COO negative, COO negative, H. Okay, so now it has -2 valency. Are you getting? So at the very first pKa, one proton is released. At the second pKa, another proton is released from this carboxylic acid. So it becomes COO negative. So there is another carbon here, right? So at another pKa, another proton is released from the NH3 group. So now it becomes this negatively charged structure, right? So this you must remember that aspartate as well as the glutamate has 3 pKa's. Okay, so if you have to calculate, so see, you do not need to remember the pKa values. Okay, at any given point of time you do not have to remember this will be given in your exam. Okay, so what they might ask is they might ask to calculate the pi. So pi is basically isoelectric point where all amino acids are at neutral position or electrically neutral at particular pH. So how will you determine that? Okay, so there's a very simple formula that you must remember. So pi, which is called isoelectric point equals first pKa plus second pKa divided by the number 2. So we have to take average. Okay, so for example, for aspartate, right, which have 3 pKa's, now what pK do you use, right? So there was NH3, I am drawing again. Okay, CCOH, H, and let's see, and COO negative, right? Not negative, COH first. Wait, COOH, right? So here it is positively charged. So when for the very first pKa, when one proton is lost, so it becomes NH3 positive, C, COO negative. So this is positive, then CH3, COOH, and H, right? So this is neutral position right now. So this pKa will be considered, right? So when it will lose another proton, it will become the negative. You know why? Because this H will go and it will become COO negative, C, CO negative, and NH3 positive and H, right? So overall charge become negative, and then this will be pKa2. So let's suppose this is pK1 and this is pKa2. We will only take average of these two, not the third one. We will not include third one in any calculation. Okay, so pi or the isoelectric point is always pKa1 plus pKa2 by 2, right? So let's suppose this pKa is around 2 and this pKa is around 3.9, and let's suppose another pKa1 was around 10.2. Okay, so for the isoelectric point calculation, it will be 2 plus 3.9, will not include this at any given point of time, divided by 2, which becomes 5.9 divided by 2, which is 2.95. So isoelectric point of aspartate is 2.95. Guys, make sure to do this calculation on your own so that you actually remember what is happening. In simple terminology, what is happening is, so we have to first look at the neutral line. Okay, so wherever this neutral line is existing, so we have to take a pKa from the left as well as the pKa from the right, and thus we will make the calculation. So for example, if we'll have a positively charged ion group, right? So for example, in case of lysine and in case of arginine, So there will be a positively charged ion, because of which there will be 2 pKa towards left. Okay, so we'll take only pKa left from the neutral and right from the neutral, just those pKa, and we'll be good to go. Thank you. If you understood, write pi in the comment box. Thank you.